Welcome to the Just Steward Podcast, a show that is about preparing the next generation in all facets of life, materially, physically, financially, spiritually, and intellectually. And I am Doug Connolly. I'm here with my co-host, Michael Frigon. Michael, how you doing?
Doing good. Thanks, Doug.
And we are here with our guest, Jake Tawney. Jake, how are you doing today?
Doing great. Thanks for having me, Doug.
Well, we're here to talk about Jake's book. I'm going to hold it up right now, my copy. Here it is. It is Another Sort of Mathematics. It is a great book, Jake. I'm about 2/3 of the way through it. That's a credit to it. I'm planning on reading it again because it's dense, but not too dense. But we're going to get to that. But first, I want to talk about, just give us a brief intro to yourself and then your history with mathematics. Before this book, you were I should say, for a long time, you've been the chief academic officer at Great Hearts, which is a fantastic charter school system that my kids go through, full disclosure. But just tell us about your history with math and then what led you to write this book.
Yeah, thanks, Doug. I would appreciate the opportunity to talk about this. I think there are really two sort of professional loves that I have. One is teaching and one is mathematics. So, my undergraduate degree is in mathematics, and after going to Ohio State for a master's degree, I ended up teaching math at the high school level for many years before jumping into the administrative side of education. And so, as you said, I serve as the chief academic officer for Great Hearts Academies, based here in Phoenix. Of course, we have schools also in Texas and in Baton Rouge, Louisiana, and are sort of in some ways always expanding. And so, while my job is to guard and protect and keep the entirety of the K-12 classical curriculum, and so I have a great love for all things in the classical curriculum. Of course, the first one there is mathematics, and I think that's important, actually, right? I think that there's a way in which within classical education, a lot of the attention has been given to the humanities, to literature, to philosophy, to history, to languages, and then even also not just the humanities, but in the fine arts, right? But not a lot of attention has been given to, I think, math and science, but maybe particularly mathematics. And that's interesting, right? Because all classical schools have math. You have to. And one of the things we try to tell our teachers when we bring in new teachers is, I never want to hear a classical school, whether it's Great Hearts or anybody else, say, we are classical and we have good math and science. We should remember that math and science are part of a solid classical education. So, this is a great job for me to hold because I'm just deeply in love with learning, deeply in love with the classical model. But I also think there's a real opportunity to start the conversation, or at least in some ways to contribute to the conversation about the place of mathematics within a classical curriculum, and what makes that different. Why is the classical treatment of math different than, say, what we might find in the typical public school? What we find often in a lot of classical schools is, and this is not a terrible thing, I think it's a good start, ironically, but their treatment of mathematics, particularly at the middle school and high school level, is just to go get a textbook that was written in like the 80s, right? Because at least it's not weighed down by a lot of the stuff that plagues the textbooks that are coming out now. But surely that can't be it, right? I mean, I think it would be a mistake to say public schools across the country in the 1980s had exactly the right model for a classical approach to mathematics. So that's who I am. That's what I do. My heart is still in the classroom, even though I guide and protect the curriculum for Great Hearts. My heart is still in the classroom, and I suspect at some point, even if it's in retirement, I'm headed back to the classroom because I really do love teaching. The book itself is just it's a labor of love. This is probably a bad thing to admit, and the publishers probably don't want to hear this, but someone once asked me, well, a lot of people ask me, who's the audience for the book? And my answer is, well, it's me. I wrote the book that I wanted to read. So I'm delighted that you're 2/3 of the way through it. I think that's great. But the motivation was I really wanted a book that started the conversation about the nature of math, but then also started to do math, right? So there are several books out there that talk about what is mathematics, why do we do it, why is it important? And I certainly give my own take on that in the first 3 chapters. Hearing that, Doug, that you're 2/3 of the way through really does delight me, because my fear is that some people are going to get bamboozled by the book. They're going to read the first 3 chapters and say, this is great, I'm very excited about math. And they're going to realize the rest of the book is actually just math. Right. The last thing I'll say kind of about the motivation of writing it comes actually from the title, Another Sort of Mathematics. So this takes its inspiration from a book that Father James Shaw wrote many decades ago called Another Sort of Learning, in which he kind of lays out all the things he thinks you should read to be an educated individual that you probably were never made to read in college. And this was a book that was immensely formative for me. I don't think it's too much to say that in some ways it prompted my foray into classical education, at least from the literature and philosophy and history standpoint. I think the same thing's true in math. I think there are results in math that are very, very familiar to mathematicians. But most people who've been through K-12, so 13 years of math education, more if you took some in college, that you've never actually seen, even though they seem to be some pretty core ideas in mathematics. And I think that, again, speaks to the fact that I don't think math is treated as actual mathematics in K-12. And so what I wanted to bring was a brief introduction to some of my thoughts on the discipline, but then also to start going through, I think, some results and some ideas from math that I think are amazing and beautiful, and I just don't think many people have seen.
Well, I should also point you wormed in Ohio State there. I should also point out perhaps the most important thing about you, besides the fact that you're Catholic and husband and father, is you are a stealth college football fan. So
I am a stealth.
the first 10 times I saw you, you were wearing a tie, probably a bow tie. So when I found out you like college football, I was mildly surprised.
Yeah, that's right. Yeah. Yeah, it's easy to be a college football fan when you're an Ohio State fan. We're doing quite well these days.
These days, yes. These days.
Yeah,
There have been moments, but yes.
there's been moments.
All right. Well, I think that I guess I would ask, what do you think that public schools, as we commonly think of them, are getting right about how they teach math, if anything?
Yeah, great question. So it would be so I have this analogy, right? This anecdote I tell that if I ask the average person on the street what a mathematician does, they really can't describe it. And I'm taking for granted, of course, that a mathematician does mathematics, and so ergo, it's actually really hard for people to describe what the mathematical act is. However, and I want to get to your question, it would be a mistake to think that what happens in K-12 has nothing to do with mathematics at all. That, of course, isn't true. So what do I think they get right? I think largely K-5 in a lot of schools, people get right. There is a way in which, like at that stage, you're learning the grammar of mathematics. You're learning what numbers are. You're learning how they interact with each other. You're memorizing facts, right? You're memorizing algorithms. I think all of that is important at that age, and it lays the foundation for things to come. So I think that is right. I would also say, although this is dwindling, the ninth grade geometry class still is a holdover of actual mathematics, right? So I went to actually a very good public district school growing up, and I remember ninth grade geometry. I remember doing the proofs. They weren't exactly the kind of proofs that I would advocate, but they were on their way, right? At least students were engaged in the acts of taking a conjecture and reasoning your way through it step by step and really presenting a proof. After all, that's kind of the end of the nature of mathematics, the writing of the proof, the rhetoric, the communication of the truth you've discovered. Again, I think some of that is dwindling in a lot of schools, but I do think there's some holdover in most schools in ninth grade of that reality. I also suspect that in most people's treatment of calculus, especially if calculus is something like an honors or an AP class, you're going to get a little bit more of that proof. I know when I taught calculus, we certainly were doing a lot of the applications. And of course, I was teaching AP, so we were driven by that curriculum. But we paused on all the major theorems and offered proofs for them. And so I think in some ways they're getting that right as well. And of course, look, they're getting the basics of the content. I mean, their students are still studying numbers, they're still studying shapes, they're studying the ways that numbers interact with each other, the properties of shapes, what they are. I think the treatment of something like algebra is too much. I think we give too much of that and not nearly enough, say geometry or number theory. But I don't even within algebra, I do think students should be able to understand how to graph a line. I think they should understand what Descartes brings to the table in connecting algebra and geometry by saying an equation has a picture and a picture has an equation, right? I mean, that's a really amazing thing that Descartes did. So I think they get a lot of that right. So I think the foundations are there. But if I'm in full disclosure, if I'm honest, I do think if we want to get this right, I think there's some substantial change to content that probably needs to happen.
Yeah, just to provide a little bit of context for our listeners, ask basically what education is done right. That implies there's a question of, what has gone wrong with education, particularly related to mathematics. And I think a lot of people are aware math scores in general, just for the broader population, has been going in the wrong direction. Kids aren't really seeing even value in math in their elementary and high school classes. But then on the flip side, it seems like math is being seen as, the most useful thing for jobs, whether it's, jobs in finance or engineering. It's kind of like this paradox where people are less interested in math. People are not really understanding probably the math that you understand. I mean, obviously, but then also it is being pushed as something that everyone needs to understand and everyone needs to be able to apply. Even like the fact that applied mathematics is becoming almost more, I don't know, maybe I'm wrong, but it seems like I'm hearing more people say, oh, I do applied mathematics. I mean, I'm making it useful. So what is your take on kind of the broader state of education as it relates to math and how that relates to, the economy? And, we're talking about this because, we want to be able to pass on wisdom and truth to the next generation. And math is a huge, important part of so much of what we do, and probably more than what most people understand. So how do we effectively steward that knowledge? How do we rediscover the wisdom of mathematics and help people to actually understand that?
And
Yes,
to
great
dovetail off
question.
to dovetail off what Michael was saying, before we started recording, Michael and I were talking about our mutual friend Mike Austin's quote. There's something unique about the human soul that can only be satisfied by wondering about mathematics. And it seems like there's this fear of math, but there's also like the only use of math. But there's this fear of math, but there's respect for what it can do from a utilitarian standpoint. But it sounds like people like you and in the Great Hearts community are trying to have a math for math's sake approach as well. And what are we losing by this utilitarian focus?
Well, we're losing a lot, and we're losing a lot because we're in to reference C.S. Lewis and his principle of first and second things, right? Lewis famously said, "If you keep first things first and second things second, then both first and second things tend to work out." And sort of classic, Lewis common sense. But the genius of his common sense is he says, look, if you invert them, you actually lose both first and second things. So I think, Michael, to your point, one of the things that the educational arena gets right, I think, is the importance of math, right? I mean, we should remember that in the 7 liberal arts, right, you have 3 arts of language and you really have 4 arts of mathematics. So the quadrivium, which consists of arithmetic, geometry, astronomy, and music, it sounds like maybe only 2 of those are math, but really for the ancients, and there's a couple of different ways of thinking about this. Robbie Jane has a different way of categorizing this, but I think one way to understand this is with the Pythagoreans, that astronomy was really geometry in motion. So it's not about the chemical makeup of the stars. It's more, you think of things like Kepler, right? The motions of the heavenly bodies. But for them, music was also arithmetic in ratio with itself. And if you play a stringed instrument like a guitar or a violin, you kind of know this, that if you cut a string in half or you cut it in certain ratios, you get certain musical intervals.
I should point out that I learned this from Donald Duck in Math Magic Land.
Yeah, exactly. So I think this is important to note that within the liberal arts, the 7 liberal arts, the 2 basic objects are word and number. It's language and number. The 3 arts of language and the 4 arts of mathematics. Right? I say number loosely there, which also includes shape. Right. So that's important, I think, even theologically. Right. The prominence of language and the prominence of number. Obviously, we in the Christian theology understand that God is a Trinity, right? But it's that second person of the Trinity that was revealed as Word, right? So within God Himself is the prominence of language, and so there's something that reaches that lives in the heavens, right, about language itself. But I got news for you and for your listeners, right? God is a mathematician, right? So He reveals Himself as Word. It's again, maybe it's reference Lewis. Tolkien does this too, but God sort of speaks the world into being. Maybe even sings the world into being. And yet, if the language comes from the 3 arts of language, which represents the eternal, the 4 arts of mathematics, right, are the kind of in some ways the things of the earth. So we find mathematics within the created universe itself, right? This is one of my arguments for the unique place that math has in any curriculum. It's that it uniquely bridges heaven and earth, right? The things of mathematics, the objects, are the things of the gods, right? The pure triangle that you've never actually seen, because every triangle you've seen has some imperfection in it. The pure triangle, the pure object of mathematics, lives up in the heavens, and yet it finds an incarnation down here in the material universe. And so it has that unique way of bridging heaven and earth. That gets to this question, Michael, about the usefulness of math. This is precisely why mathematics is useful. It's useful because even though its proper objects are immaterial, they find approximations, they find real participation down here in the material universe. So what I think the educational apparatus gets right is a focus on the importance of math, right? I mean, look at any standardized assessment. Like for the most part, we're talking about an ELA exam and a math exam. And I know different states will have a science exam here and there and a history exam here and there. But if you look at the numbers, usually it's only 1 or 2 grade levels, right? College entrance exams are usually only ELA and math. And with due respect, this is not to dismiss the importance of the study of history, the study of science, but I do think there's a recognition that even the educational sphere gives that those two things have something of a priority. Now, what it gets wrong is it flips that. It seems to think that the reason why there's a priority is because of the usefulness of math. And math is useful, and that's a beautiful and wonderful thing. It's amazing to me that mathematicians will play with numbers and shapes and structures and discover beautiful things. And then it's decades, centuries, sometimes millennia later when the engineers and the physicists and the economists all of a sudden find applications for those age-old truths of mathematics. So I'm not down on application. What I am down on is flipping that relationship. We should study math because those objects are real, and real things deserve to be studied and internalized. And I think that's what Mike Austin's getting at when he says it satisfies something unique in the human soul. If we get that right, the applications will continue to come. I mean, there's a very practical concern I have, even just for advancements in science and engineering. If we're going after those directly and not promoting the actual study of pure mathematics, I think using Lewis's principles, both things will suffer, right? I think, again, because applications often lag behind by hundreds, thousands of years, if we're not doing that work within pure mathematics now, we may actually be hindering the second thing itself, right, which is the application.
Well, something I wanted to discuss as well is we just to drill down into some of the content that's in the book. Again, it's clear. I want to make it clear to everyone. I have an undergraduate degree in math, and I used to teach 7th grade math. And I think the difference between Jake and my understanding of math is about as large as the gap between my understanding of math and my 7th graders that I taught. So it's just amazing how you get to someone who really knows math and how impressive it is. And you pull in history, and you do make it come alive. And again, it is not just one of these books you pick up in the airport and thumb through. It's written for, I think, a wider audience than what one might think, but it is something you want to think about. And you say that you're upfront. You want people to ponder these things. But one of the most accessible subjects that I thought, and something that was interesting, is particular proof that you talk about that 0.9 repeating equals 1. I think you offer 3 different proofs for this, but I thought and what I want to be clear is that 0.9 repeating is not close to 1, not infinitely close to 1. It is 1. Can you expound on that, Jake?
Yeah, I mean, I think I said somewhere in the book that this is right, that many students, whether this was presented in in middle school, which I think is the first time I saw it, with no justification, right? When we were doing repeating decimals, right? Or whether you see it in high school where you start to get a little bit more justification, or certainly in calculus when you can have sort of a full formalized proof of it. What I think I said in the book is many a student has argued with their teacher about this, right? And saying, look, it's really, really close to 1. I get that. Or even going so far as to saying, it's as close as you want to 1, but it's not 1. And it turns out, actually, it's true. Now, it is equal to 1. Now, what's kind of interesting about this, though, is almost nobody argues with 0.3 repeating being 1/3.
Yeah.
It's like that decimal is so familiar to us, we've accepted that. I think that both those facts deserve to be accepted with proof, but also deserve to be challenged until there's a proof. And I say that just to note that I do think it's interesting that people have no trouble accepting 0.3 repeating being 1/3, but have a ton of problems accepting that 0.9 is 1.
Well, correct me
And
if
I
I'm
meant,
wrong, but isn't the fact that the 0.3 repeating, maybe I'm using circular logic, but for me, I have an easier time accepting that. I've come around to the 0.9, don't get me wrong,
Mhm.
but I have an easier time accepting that because 0.3 repeating can actually be written better as a fraction, whereas there's not really a better way to write 0.9 repeating as a fraction.
Yeah, it depends on how elegant you think the fraction 1/1 is. That's a pretty elegant fraction to me. So I think the reason why people accept the 1/3 as 0.3 repeating, though, is because they know how to take 1/3 and do it as a division problem, and they'll see the threes coming up over and over and over again. In other words, and maybe that's what you're getting at, the proof for 1/3 and 0.3 repeating doesn't have to go from 0.3 repeating to 1/3. It can go the other way around. You can start with 1/3, do the division, and see the threes keep coming up. You can't do that with 1/1, to your point, maybe, right? If I just divide 1/1, it's not like I'm just going to start getting a bunch of nines. You have to be really clever in how you're doing that. But I do bring up 0.3 repeating, not only because it's accepted, but because that at least offers a less formal proof, but at least the idea is the broad strokes of a proof for why 0.9 repeating would be 1. I mean, after all, if you take 0.3 repeating and you multiply all the digits by 3, you get 0.9 repeating. So 0.3 repeating times 3 is 0.9 repeating, but 1/3 times 3 is 1. And that's a pretty intuitive proof. Again, if you know some calculus, for the mathematicians listening, there are certainly some issues that need to be dealt with in that. But I think for most people, that's a pretty intuitive proof for why 0.9 repeating has to be 1. The other intuitive proof, and I think actually most of my high school students bought this, is, look, there's a property of numbers that says if they're not equal, one of them has to be less than the other, right?
This is my favorite one. I like this one.
And it does seem clear to me that it's clear to everybody that 0.9 repeat is not bigger than 1, right? So it's either less than 1 or it's equal to 1. And the beautiful thing about any two real numbers is if one's less than the other, there has to be a number in between, always. And I know that because I can average the two. That's not the only number in between, but the average of two numbers that are not equal is always between the two numbers. And so if we think 0.9 repeating is not equal to 1, we are obliged to find a number in between. And you can't do it. No matter how hard you try to construct that decimal, you can never find something that's in between. And if that's true, you have to then admit the only other possibility, which is that the two have to be equal.
Yep, that's the tidiest proof that I think there is.
Yeah.
Thanks for.
But we should reflect here, though, on I mean, I don't know if this is a philosophical principle, a theological principle. It's certainly an aesthetic principle. The idea of a decimal is really that we're just adding up a bunch of things, right? I mean, decimal is just a notation, right? It's a notation for a bunch of fractions being added together. When we say 0.99, we're talking about 9/10 plus 9/100. Like, that's it. Decimals are just notations. And they're notations that represent the additions of fractions. So if we understand that, then what we have with both 0.3 repeating and 0.9 repeating is an infinite number of things being added together, and we end up with a finite result. I mean, that's mind-blowing, actually. Now, again, for listeners that have, a little bit more math classes, maybe a degree in math, like, you've seen this in calculus. This is so second nature. But one of the points I try to make in the book is, even though some of this stuff is second nature to us, like the angles in a triangle adding to a straight line or 180 degrees, we should pause and say, that's not at all obvious that should be true. That's actually an amazing fact that that's true. And in this case, we're dealing with somehow the infinite becoming finite. Now, I'm not a theologian. I'll leave that to your listeners who are theologians to reflect on that. But there does seem to be something there about the incarnation, right? The infinite God becoming small, becoming finite. And the idea here that we have an infinite number of things added up and that we end up with a finite result. I mean, I don't know whether that's theological, but I do know that it should be mind-blowing for us.
Yeah, I'm going to ask you a little bit to venture in, just for our listeners because I think this is actually something that a lot of our listeners can really learn from. You mentioned over and over again, the theological nature of, or the relation of mathematics to theology. And I remember when I was reading St. Augustine and his, proof or his reasoning for the existence of God, just based on, just the fact that there is a God, not necessarily the God of the Bible, but the fact that 2 + 2 = 4 being absolutely true, and we can't change as humans, being a proof that there's a reason above human reason. And so that had an impact on me in my faith journey and getting to understand, like, actually, yeah, that does make sense reasonably that there is a God. So what are some of the ways that, and you can speak broadly, it doesn't have to be just on the Catholic Church, but just Christianity in general. How can mathematics be used as an evangelization tool, as a a catechism tool, or should it be used that way? I mean, is this something that is being left on the table for the other, a very important task of ours is to pass on the faith. So how can we use mathematics in that way? In your opinion, even if it's not your specialty in terms of theology?
Yeah, I know it's a great question. I have so much to say about this. First, I appreciate the reference to Augustine. It reminds me of the proof for God's existence, and I think he's probably riffing on Augustine and others that Ratzinger gave. And I can't remember if he gave this as Ratzinger or as Benedict. I just don't remember the timing of it. But what he said was the fact that the laws of mathematics, the way that the universe seems to work, and the way that the human mind thinks, the fact that all those things are consistent with one another shows that there must be something above them holding those in tension, right? I mean, imagine a world where the laws of mathematics were different than the way the world was created, right? Like you couldn't understand it. Or imagine maybe those are congruent, but the human mind works very differently, so that we couldn't even understand these laws of math or the way the universe works. All of a sudden, the world is not knowable anymore. And so the fact that those three are consistent with one another, Ratzinger saw as a proof for God's existence. So there must be some principle above them holding them together, or another way of saying it, they must stem from the same principle. So I think that's a beautiful thing. I think it's a beautiful reality. How do we use math for evangelization? I do think we need to be careful here, right? Math is beautiful in and of itself as created by God, right? I mean, that's the first thing, right? Is that anything that exists has been, and as having been, it ultimately is a participation in God himself, right? And that's why it deserves to be studied. All disciplines follow the Mike Austin principle. They satisfy something unique in the soul because they're ultimately all a study of being itself. This is why, by the way, you don't need applications in order to motivate them. Being should be interesting and beautiful in and of itself, because being ultimately participates in God, who is pure being, right? Pure act. The reason I think we need to be a little bit careful is there are extreme versions of this, right? Where, my wife and I homeschool, up through, I should say my wife homeschools. I do a little bit of Latin with them, but my wife does all the hard work. But, we've seen several homeschool curricula where, the idea of sort of Catholic mathematics is word problems that have to do with rosary beads. And, I mean, this is not a terrible thing, but this is certainly not what we mean by sort of an authentic approach, Catholic approach to mathematics. I think the place to start with evangelization is to recognize math's unique role in what it does for soul formation, right? And this is what I mean. This is not an exhaustive treatment, but at least it's the beginning of a treatment, right? In a world that has like relativized almost everything, and truth seems to have this, of truth, goodness, and beauty, right? Beauty long ago was relativized in the eye of the beholder. Goodness, we know, has been relativized in terms of the way that we think about moral action. Truth seems to have this last stronghold, but it's dwindling right now, right? Truth itself is starting to become seen as something relative. I think this is where math comes in, because math says, along with Augustine there, when you learn that 2 + 2 is 4, you are learning something that is objectively true. And not only objectively true, but true forever. There are things that are objectively true that will change. Right? My reading glasses have a prescription of 1.25. Over time, that will change. I mean, I suppose there's a way of saying those reading glasses themselves will always be 1.25, but my prescription will change. So something can be objectively true and not eternal, at least seen in a certain way. But the truths of mathematics are objectively true and they're eternally true. And as we kind of said at the beginning of this, they're truths in things not made of matter. You've never seen a perfect triangle. It's an immaterial object, and yet you can say true and eternal things about them. That is math's unique role right now, probably always, but certainly right now in the educational endeavor. It teaches students that there are truths in the universe that are objective, eternal, and in things not made of matter. And so ultimately, then that points to God. It demonstrates, like once and for all, that there at least is something that is eternal and immaterial, right? And so once you have that, you kind of pave the way for the existence of God, right? And things like that. Look, I think there are other things that can help evangelize. I'm always interested in how people come to the faith. I think all people come either through truth, goodness, and beauty, but probably all three, but they usually have one of those weights more. I'm a cradle Catholic, so I came to the faith through baptism of the baby, but I do know that my initial attraction as I kind of grew into young adulthood and accepted the faith kind of for myself, for me, probably won't come as a surprise, came through truth, right? Rational arguments about this. But I know plenty of people who came into the church because they saw a beautiful mass, right? And so it's beauty that brought them there. And then certainly people who say, like, look at the church's teaching on something like contraception and say, look, this is like the only church that has actually maintained the truth of this. And so it's sort of goodness or maybe interaction with people who are good people that brings them in. If math is to bring people to God, it has to do one of those three things, right? And so, either emphasizing that eternal truth of it or maybe emphasizing the beauty of it, that's how math will point to God. But I do think we need to make sure that we're not being superficial in this. And that's probably particularly important for some of my math colleagues who teach in Catholic schools, right? You want to disclose the beauty of mathematics, and you certainly should say that points to God. But if this becomes like every lesson is about trying to connect math with the catechism or theology, this can become superficial and really, in some ways, just outright fake.
Well, you see that in other forms of art, not that math is an art. You might say it is. I don't know. So the line becomes blurry when you're talking about subjects classically. But for instance, someone like, there's a difference between even if we look at modern, the Catholicity of someone like, say, Walker Percy, when he in his novels versus what, evangelical fiction as we commonly understand it today. And that a lot of these great Catholic books, both classic and modern, they are Catholic without even hammering you over the head. That's the beauty of the Catholic approach to art. This all-encompassing worldview that doesn't need to superficially tie something to the faith to be true, beautiful, and point to God.
Right, because it takes seriously the principle that all being ultimately points to God. So the most important thing in writing a novel is to write a novel that is true, right? Yes, we want elegant language. We want, but ultimately the purpose of a novel is to disclose the human condition, right? And if you disclose the human condition in an accurate way, it ultimately does point to God, right? It fails to point to God when it starts to disclose, the human person in a way that's false, right? But you're right, and this probably is a little too much for right now, but this probably gets in some ways to some of the distinctions between like Lewis as an allegory and Tolkien as non-allegorical. This is not to dismiss Lewis. I think there's a place for allegory. But I think somebody like Tolkien would say, look, we're trying to write a good story, and a good story that is ultimately true, even though it's fiction, right? And if you do that, if you write a true fiction story, then you ultimately have produced good art, and you've ultimately drawn people's minds up towards God, because anything true is a participation in being, and being ultimately points up to God.
Well, I want to ask you before we get out of here, we got 5 or 2 more minutes. What is your favorite corner of this book?
Yeah. As you can imagine, that's a hard question for me to answer. I have so much passion for all the chapters that are in there. I do think, let me just name 2 of them. One, I think, will be widely appealing to lots of readers, and that's the chapter on the bridges of Königsberg. And that this is a particular town, Königsberg, that has 7 bridges connecting various masses of land. And this is all a very true story. The people of Königsberg wondered if you could travel across every bridge exactly once. You start wherever you want, you can end wherever you want. You got to cross every bridge, and you can't cross back over a bridge. Can it be done? And like all interesting math problems, it became interesting because it was hard. And so the people started asking, is it just hard or is it impossible? Right. And that's where math steps in, right? Math steps in to say, can we either find a solution or can we offer a proof that you will never be able to find a solution?
It
And
seems like people accepted the fact that it was impossible, but they were looking for a proof as to why.
Yeah. Yeah. And so what I love about how this proof happened is 2 things. One, and you have to go kind of read this chapter. So I encourage the readers to grab the book, and you can actually skip straight to this chapter. It doesn't rely on anything that comes before it. But there's a really creative moment that happens in the proof where instead of focusing on the bridges, which really is the focus of the problem, you focus on the land masses themselves. And you count the number of bridges coming into them, and you start to ask questions about what it means to visit one of the land masses. And I won't give the proof away, but it relies on the principle that what comes in must go out. Like if you come onto a landmass through a bridge, you have to exit it, right? Unless, of course, you start or end there. And so I love that moment of creativity that happens, right? There's this moment of insight of saying, maybe if we focus on something different, maybe we invert our view of this, things become more clear. It turns out they start to become crystal clear. And the other thing is this very simple seeming puzzle, right? I mean, I gave this to my elementary kids. They can't understand the proof of this, but they can play with it and they can start to say, oh, maybe I can do it this way. Maybe I can do it that way. The simple problem that comes off as a puzzle ends up giving rise to an entire area of mathematics called vertex edge graphs. And it turns out, again, principle of first and second things. When it was about play, when it was about pure forms, we weren't worried about massive applications in engineering. Those applications came later because these vertex edge graphs now govern flight patterns. They govern anything that can be described as having connections, right? So internet networks, all are based on this principle and these problems surrounding vertex edge graphs. And so I love that about it, right? I think it's a pretty accessible chapter. It doesn't require anything that came before it, and it stands out as something a little bit different because it's not about number, it's not about geometry. So this is not arithmetic, this is not geometry, and yet it is unabashedly mathematics. The other chapter that is maybe my favorite in the book, but this might speak to me as more of a mathematical philosopher than a mathematician, is a chapter on Gödel's incompleteness theorem. I spent a long time and a lot of revisions on this chapter. And how do you take such an important theorem and get that down to a point where people can understand what the theorem says and maybe importantly, like what it doesn't say, but then also start to sketch a proof? Because this is a really, really hard proof to actually go through. So this chapter is located in the section that says, theorems you should know, but the proofs are really hard. So we're not going to go through the whole thing. But I was pretty happy with how it came out, kind of sketching the major steps of this. I love that chapter because I remember hearing that theorem for the first time, a theorem that ultimately talks about the limitations of the mathematical act, that ultimately there will be truths in mathematics that will never be able to be proven or disproven in a purely formal algorithmic way. And so this is really important for our age because now we're in the age of AI, right? We're in the age of algorithms. And even an advanced neural network, a large language model, even though it's super complicated, ultimately it's still what computer scientists would call Turing computable. It's still algorithm underneath. Right. And so there's a lot of question about what can that kind of thing do by way of proving math. And Gödel comes in and using mathematics itself proves that there will always be theorems that can be neither proven nor disproven with a purely algorithmic approach to writing proofs. And that seems just immensely important for our age. So historically, it was important for me because I remember this theorem and thinking this is amazing. I think in the present time, it's important because of all the currents that are going on with AI. And then again, just the challenge of trying to write that in a way that I think people are still going to have to struggle through it, but at least write it in a way that's mostly accessible. I think it's an important chapter.
All right. And I'm going to give the final word to Michael. But before that, I want to just say, again, get the book, go to Amazon. You can grab it there. Most importantly, with all books, the most important question is, will it look good on your shelf so that people think you're smart? And the answer to both questions is yes. It will look good on your shelf and people will think you're smart. Also a joy to read. But I want to ask this. I think this book will have a long life. I think you'll see sales steadily. I think it'll become in certain corners a classic because I think it fills a very valuable need. What is your next book going to be about? Because you got to write another one.
It's a great question. I have a couple ideas for a next book. I mean, one in the realm of math, there probably is a more practical book to be written that's shorter on something generic, like a title that's generic, like how to teach mathematics in a classical school, right? Outlining some pedagogical principles. So there's that. I've often thought this broadening out from math that a very easy to understand, very short book, not a pamphlet, but a very short book that's almost a Q&A format for parents on what is classical education. What are all the questions they have about it? I think that Q&A format could be very digestible for something like that. And then I'd always have a novel or two in the back of my head that I probably never will get to.
Michael, you got a closing question for us?
Yeah. So I'll ask the final question we ask all of our guests. I want you, in your own words, to explain what stewardship is, what it means to you, and how we can all be good stewards. You can take it from your own specific perspective on mathematics or just general. I just want to know your thoughts on stewardship.
Yeah. This might be a unique take. Maybe it's not. Maybe everybody says this. I don't know. I will start just with the basic charisma of the gospel, right? We are all sinners and we need a savior. And God became man in the form of Jesus Christ. who saved us from our sins by dying on the cross and rising again. I start with that because ultimately our entire life is about accepting that truth and surrendering that truth so that, God willing, we can stand before him someday at the gates of heaven and hear those words, "Well done, my good and faithful servant, welcome home." But also to note that we are not just individuals, right? We are persons in communion. And so it is not only my job, certainly it is, that universal call to holiness to be able to stand before God someday at the gates of heaven, and to hear those words from him. But also we are all our brother's keepers. And so ultimately we are trying to get ourselves into heaven, to get others into heaven by preaching that basic charisma of the gospel. How does that relate to stewardship? Whatever the gifts we have, whether it's talents, whether it's finances, whatever the case may be, we are stewards over those. They are not our own. They have been given to us for a purpose, and we have to understand that purpose. And that purpose is to get ourselves and to get others into heaven and to bring them into that heavenly reality so that we can live forever worshiping the God of the universe. So whatever gifts we have, whatever we've been given, they're there for a purpose, and that purpose is Jesus Christ.
That's a great answer. Thank you so much, Jake.
Yeah, Jake, thanks so much. And again, Jake isn't the kind of guy to have, you don't have a website or social media or anything like that, do you?
Just LinkedIn,
Good call.
which is really new since the book.
I will say this about one random thing about your book is that I was scrolling through and I was like on the federalist.com and it said, I think I was the one who brought this to your attention, but it said like, oh, good new book on mathematics, and I was like, this has got to be about Jake's book. And there it was a review of Jake's book. So, that my idea of someone being big is that you stumble across your friend when you're not even looking for them online. So I think that this book's been well received. And I think it's going to continue to gather momentum and fill, again, as I said, a valuable space in the education sphere.
I appreciate that. Thank you so much.
All right. So again, thanks for joining us. And you can find our company's website, taylorfrigon.com. If you want to learn more about us, subscribe to our Substack and get some more thoughts on stewardship, investing, and overall financial management. And again, thanks to our guest, Jake Tawney. Go out, buy his book, read it, share it with others, and think about math. Thanks for joining us, Jake. Thank you, Michael.
Thank you,
Thanks,
Michael.
Jake.
Thank you, Doug. Appreciate it.